the next thing we're going to go through is we're going to look at the next project. And what we're going to start doing is we're going to start formulating a frequency display. So this project works exactly, it takes the exact same stuff. We're going to use the Adafruit SSD 1306 library and the graphics library. It's going to look very similar when I get over here to the code. So let me close this out and close this out, and I'm going to switch my default project. So we're going to use this guy here, and see where that Mark, you saw that pop up and it was checking things. That's when it should actually load up your libraries if it doesn't have it. All right. And so now this is the main for this. Now there's some additional stuff that I've added in here, and so I'm going to annotate this as we go through. Defines for so we start out again with the same three headers: Wire H, Adafruit, Graphics H, and Adafruit SSD 1306. All right, and then the next is, again, we've got our screen width and the height, 128 by 64. Now these these defines for the frequency display, these are the divisors, because if you remember back when last week when we were playing with the SI 5351, you provide the frequency for that in hundredths of a hertz. So what we have to do is, in order to take that value and break it out and get the megahertz value and the kilohertz value and the hertz value, is we're going to have to divide that frequency value that we're using by several different numbers. And then here again, we're setting up the global variable for the display. Now, right now we're not going to use these constants, but what I've done is I've put in the constants for the bands. You know, we've got 160, 80, 40, 20, 15, 10. And then the lower and upper frequencies for each band. And then the current band, this is going to be an index that we're going to use for each one of these. So right now I've got it set for number 5. And anybody that's new to programming, in the programming world, we don't start with 1 when we're talking about indices into arrays. These are called arrays. We start with 0. So if we were to count starting with 0, we go 0, 1, 2, 3, 4, 5. And so that would mean that we're starting up with the 10-meter band as our default band when the program starts. And then this array here, we're going to keep track as we go along and build out this VFO. We're going to keep track of whatever the current frequency we are on each band, so that when we come back to that band, we actually will pull that in and it'll change it back to where we were before. So not only am I going to give you the ability to manually change it and switch bands, but as long as the ESP32 is running, it'll remember your frequency that you were on. And then we've got the target frequency. We're going to use this as we start playing around with the rotary encoder and that. We're going to keep changing that, and that'll be what we actually send to the 5351 whenever we change frequencies. And right now I've got a frequency step at 1 hertz. And then I've created some functions that we're going to call like clearDisplay, showDisplay, display the frequency, and we're going to pass in the target frequency to it. And then we're going to also have displayBand. So we're going to actually, when this runs, it will display whatever frequency we have set that we're tuned to, and then underneath it'll say band in 80 meters or whatever. So in the setup, all we're going to do in the setup right now is we're just going to set up the serial monitor, and we're going to make sure that we can talk to the OLED display. And if not, then we're going to bail and just set in a for loop that goes on forever. Once that's done, we're going to take the target frequency and we're going to set it to the current band, to the current frequency for the current band, which right now should be basically the low end 28 megahertz for the 10 meter band. And then our loop, we're just going to go through and we're going to clear the display, display the frequency, display the band, show the display, and then we're going to delay for 10 seconds because right now we're not doing any frequency hopping or anything. So we're not doing any tuning. We're going to, after we get done with the encoder, we'll actually go through that. For clear to the display, what we're doing is, and this is actually what we had done before. We set the we clear the display, we set the text size, we set the color, and I'm setting the cursor to the upper left-hand corner at 0, 0. And then for show display, I'm just calling display.display, so it'll render the display. Now, display frequency gets a little convoluted because there's not an easy way to format a long integer into what we're familiar with, which is megahertz, period, kilohertz, comma, hertz. So what I've done is I've got little sprintfs in here so we can see what we're doing, but we're going to basically create an intermediate variable for the megahertz. And so we're going to take the frequency and we're going to divide it by that megahertz divisor. So that should give us back 10 or 28, excuse me. And then I'm creating a buffer that we're going to use to display on the screen. And I'm formatting that by using this little %D. And that's going to basically give us, it's going to take that integer and it's going to create a string out of it and stuff it into that megahertz character buffer. So it's going to basically take whatever this value is, format it into a string, and stick it into this variable. And then what we're going to do is we're going to subtract that from the frequency that we were passed in. So now we should just have kilohertz and hertz. And then I'm doing an intermediate so I can make sure that I get the same thing. Then we're gonna do the same thing we did with the megahertz. We're gonna divide it by the kilohertz divisor, and we'll get our frequency and our kilohertz, what that is. And then we're gonna do the same thing here. We're gonna take that frequency, but this time we're gonna force it to be 3 digits wide, and we're gonna pad it with 0 so that when we're at 28.001, we get 001 and not just 28.1. So we're using that. Then we're going to subtract that off, and that should leave us with whatever the hertz is. And then another little printout so we know what's going on. And then we're going to do the same thing for the frequency. We're going to divide that by, so that all we have is the hertz. We don't care about the hundredths of a hertz. And then we're going to do the same thing by formatting it and sticking it in the hertz screen. And then what we're going to do is we're going to combine all those together to be formatted the way we want. So since these are all characters, we have to use %s to tell it that I want to take the first character string, then put a period, then the next character string, then put a comma, and then the next character string. And then we're going to print that out so we can see what it's supposed to be formatted. And then we're going to set the cursor, set the text size, and then we're gonna print that buffer. And so what we should get out on our display should be 28.000, 000. And then the display band, what we're going to do is we know that a size 2 text is 12 characters or 16 characters deep. And since we're starting at 10, we'll take 10 and add 16. That gives us 26, and then we're going to add 2 more pixels to give us a little bit of space underneath that so that the text is not on top of each other. We're going to set our text size to 1, and then we're going to print out band, colon, and then whatever that integer value is, space meters. So, and we're basically using that array up there, the band switch, and whatever the current band is. So in this case here, it should be 10. Any questions on the code?
Yes, Bill McNichols.
Go ahead, Bill.
Did you type every one of those lines yourself based on your knowledge, or did this pop up as you went?
I typed most of this in my knowledge. I also like the frequencies in that. There are, matter of fact, let me switch over here to the browser. There is, did I put it here? Oh no, let me go find my thing here real quick again. I think if I go to GitHub, I'll find it. I've got to switch over to the browser real quick. There actually is a library. If we go out here and we say ESP32 SI5351 VFO, there's several people that have written libraries. And so, and this is kind of where I built a lot of this off of. I've been doing a lot of running down rabbit holes across the internet, but he actually has a library that actually is specifically to do a VFO. Now he's using a different display. He's using what they call a Nexion display, which is a much more graphical display like this. And it even has an S meter, and it has tabs down here to tell you what your function in that is. But what I did was, if you go down in here to this folder here, and we look for, let's see, where is it? VFO, I think it's this guy right here. Nope, it's not that one. Sorry. VFO.ccp. So what I just basically stole all his definitions, so it would make it easy for us. But somebody someplace, Bill, did type everything.
If everybody else knows this and I don't want to hold you back.
No, that's fine. There are no dumb questions. The whole idea is if you're going to build something and you're going to use a microprocessor to drive it, you need to be able to understand where to go look to try to play with stuff to see why it doesn't work, right? And so, please, everybody, you got a question, you don't understand something, ask it. I'd much rather take the time to explain it and everybody, understand it than you be left behind and say, well, geez, I just spent, $100 and I wasted my time. So to me, that's.
I'm learning. Thank you.
Okay, so anybody else have any questions about this little program? Well, then let's see if it works. So I'm going to go ahead and build it and run it. Come on. There we go. And then just so you can, I'm going to leave it on the terminal first, just so you can see it once it runs through. You'll see it. Let's kick over to the terminal here real quick. So you'll see here that it basically, here's your display frequency, 28. That's the, I guess, there we go. So it's just going to run through that every time. So now let me switch over to the overhead view. And I don't know if you guys can see it very well, but it says 28 dot. I may have to just get over to the Mevo and see if I can't just zoom in on that. I think that's as small as I can get. Can you guys see it okay?
Yeah.
It's a little blurry, but we can see it.
Okay. But so if I go up here now, what I'm going to do is so we've got a way that we can now display the frequency in a format that we're used to as hams seeing, right? And we also got a way to display the band. Now, if we wanted to also put a mode, we could switch back over here to and let's say that we could go in and add for a mode, like if we're going to do upper sideband CW or whatever. So what we could do is we could do let's see, constant care. No, I got to do string, excuse me. Modes. And we're going to say equal, and we're going to say quote USB, comma, quote LSB for lower sideband, comma CW, yep, comma, let's say we're going to do digital as our last one for like FT8 and that. But we could, if we were, well, we could do like whisper as a mode. We could do quote FT8, comma, quote FT4. And we put our little, and then what we're also going to do is we're going to put another integer in here, int. We're going to say current mode, and we're going to say that, let's see, we got 0, 1, 2, 3, 4, 5. So we're going to say current mode equals 5. And now we're going to add a new definition here, display mode. And then let's go, we're going to go steal the display band function and we're going to modify it. So we're going to call this display mode. So I need to see, okay, so we're 8. So what we're going to need to do is add 10 to this. So we're going to make it 38 because since we're in text size 1, that's 8 deep. And we want 2 pixels, so we're going to say 38. And then we're going to say mode. And then all we're going to do is we're going to change this because that is a string and not a number. We're going to do, what do I call it, modes. And then change this to current mode. So now we also need to make sure that in our display function up here that actually draws the screen, that we actually, before we do the show display, we call display mode, semicolon. So now we should have 3 lines when I'm done here. So let's try it. Oh, he didn't like that. We got an error. That's because I don't know
you
how
need
to.
an S, yeah.
Yep.
And the one above it needs an S to display.
Well, I wonder how come it didn't. Oh, you know what? It probably does, but I should do it the easy way down here. It is display, right? And that is display. So let's do S here. Yep. So let's go put we'll put a S up here now. And oh, but I probably also need to do it up here. Well, no, there's display mode. Void display mode was not declared in this scope. Void display mode.
Right above it.
All right, I'm just going to do it the easy way. Come down here, we're going to put that there, and I'm going to make sure that this guy has it as well. Let's see if it builds now before we try to push it. Sometimes the little squiggly lines, which is the interpreter, he says, okay, now displayBand isn't there. So I need to come back up here and I need to define this as displayBand instead of displayBand. Okay. But that's the nice little thing about it. You see the little red squiggly lines, that tells you there's something wrong. And if you hold your mouse over it, it will say, here's your problem, right? Now everything built successfully, so we can actually now display this. So we'll go ahead and we'll kick off the upload. So it's going to rebuild it for release mode. And then I'm going to reset the thing, the ESP32, and it's going to load it up. And then I'm going to switch over to the overhead view. And so now you should see 3 lines there. You should see the frequency, the band, and I'm going to bring it up a little higher so you guys can see it. Guess it's not going to stay in focus. But I guess it doesn't like it. Okay, this way and towards me this way. Okay, so that's pretty much it for display for right now.
Quick question, Jim.
Yeah.
Is there a way to control that interlace speed on that screen?
Well,
That's
that is
because of the camera.
Yeah, it's because of the camera. I'm
Oh,
running
okay.
at 60 frames per second, and so you're getting that. But if you actually look at it physically, Steve, you can't see the interlacing.
Got it. That's pretty cool.
Okay. Okay, so let's see. We're almost to the hour. Does anybody want to stick around and do the encoder stuff, or do you guys want to wait and do that for our next get together?
I think I ought to wait and do it the next one.
Well, I'm sure a lot of people's heads are like, "Oh my, that's way too much."
Well, I'm kind of going to catch up. What I've got to go back and look at the other 2, at least last week's video, and the one before that I missed because I was out of town. But
Yep.
Yeah, me
But
too.
Steve, did you need parts or did you order them all?
I got everything. I got my list built. I'm going to order them tonight and tomorrow morning.
Okay.
So I can,
Well, like I said, I still have one set of parts, everything but the ESP32 and the breadboard. So if you want to just get those from me, I can provide them to you. That way you don't have to order them.
okay. All right. I'll get with you tomorrow and
Okay.
just go through that list to make sure I got everything covered. Yeah.
Okay. And for since you missed the first session, one of the other things is there's no we're only going to use a couple of resistors in that when we start playing around with stuff. So if you want to hold off on buying the resistors and the capacitor sets, more than likely you may already have them if you've done, you've been working on radios or something, or you've been playing around with Arduinos and that. So you don't need to buy them, but also, like, I've got a bunch of them. Roger has a bunch of them. When we get into that part, we have them. But if you've already bought them, that's great. But
Yeah, I've got some inventory of stuff. So those things I don't care, not too concerned about. It's just the other critical pieces there. So
yeah. And other than that, anybody have any other questions?
Bill McNichols, I bought the resistors and everything, so I'll give you what you need. This falls under a truism in life. You don't know what you don't know. So this is really enlightening, looking at the programming. Thank you.
Hopefully, well, and it may spark something in you, because once you get this working and that, you may say, well, heck, I'll just build my own. But it'll also help you understand some of the kits out there, like the QCX and like the True SDX and some of the other ones that like you can get from QRP Labs or QRP guys. This is the basic fundamentals of what they do. You just don't ever see it in the background because they give you a bin file to upload to it. But the other thing is that, like we were talking on the very first meeting, that the SI 5351 is actually a cornerstone for a lot of equipment that we use. I wouldn't be surprised if it's in any in the a lot of the antenna analyzers and that, like the Nano VNA uses it. My Tiny SA spectrum analyzer, it uses it. I know the KX3 and the KX2 uses it for their oscillators. So this will help you understand what's going on as well from that perspective.